Anybody, any other questions at all?
I had a question.
Yes.
For 9.3, it asks us which distribution we're supposed to use, but they give us 3. Are we supposed to assume that the distribution is supposed to be normal, so you use the binomial and the student t distribution, or would it be the
So binomial would never go with t. And the thing I don't like about the way they set up 9.3, we know that we have to have a normal distribution to be able to do anything. So really, their real question is, do you use z or t? That's the real question.
Okay.
Yeah. Anybody else? Anything else, guys? Okay. All right. So we're going to get into, actually, I mean, we finished chapter 9. So I had a big chunk of time set aside at the beginning for any specific questions anybody had run across. Has anyone gotten into section 9.5 yet?
I have.
Okay. 9.5 is where the full tests are. So Veterans Day is this Wednesday. So that's no classes this Wednesday. It's so weird. I can't remember the last time we had a holiday in the middle of the week. It's weird. So today is the last day of class this week. All right, so some more people just came in. Any other questions before I just keep on going? All right, I'll accept it. Just get in at 9.5, get some freaky stuff looked at. So you got some questions for me. The only thing I have, well, let's see. Do you want to, all right, let me ask you a question. So do you want to do an example of a certain type? What types of hypothesis tests have we looked at so far? Can somebody give a guess as to how many types of hypothesis tests we've looked at?
2.
2. Okay, I like it. I would have accepted 3 possibly, but I like 2 better. There's a hypothesis test for mean, and there's a hypothesis test for proportion. The mean has kind of 2 things in it, right? Z-score, T-score, but that's not really a difference. How are you guys doing out there? Sort of like this. Let me ask you this. How many formulas are there for confidence intervals that we know of? Let me throw that in there.
3.
Good. Yes. 2 of them have the mean in it. The only difference between them is Z and T. So that kind of mimics the hypothesis tests we've done. Does that make any sense? Maybe, not really. It's like, what the hell are you talking about, Jeff? All right, I understand. I get that a lot. All right, so let me ask you this. Do you want to do an example of a hypothesis test that we've already done? Or do you want to get into new stuff immediately?
I want to do an example problem.
Oh, okay, all right, let's see.
Yeah, I feel like that would be a good idea.
Is that a good idea?
I'm like 70% there.
I understand. Let's see. Let's do. Oh, okay, that's right. We get more interesting over here. Here we go. Let's take one out of the section in the book, just so I can do one just like the book has got. But I don't want to do your homework for you, so let me double check what I assigned exactly. You're like, oh, Jeff, it's okay. You could do it. Don't worry, man. Don't do the extra work of looking. You could do our homework for us. You guys are so good. You guys are so nice. Let's see, 80, 81. Okay, so I can do any of those. Sweet. So let's see. Let's pick one. I'm going to throw this up here for a second. Bam. Let's see. Sure. All right, this is really pathetic. Let's do number 80 because it's so pathetic. Your stats instructor claims that 60% of the students who take her elementary stats class go through life feeling more enriched. For some reason that she can't quite figure out, most people don't believe her. You decide to check this out on your own. You randomly survey, blah, 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 blah. What do you think? So this one is an interesting problem because it doesn't, well, okay. Can somebody tell me what the claim is? That's not hard. Can somebody tell me what the claim is?
60% of students leave the class feeling enriched.
Good, I like it. Now, what would it be in mathish?
P is equal to 60%.
Yes, good. So this is one of those where people sometimes have trouble because it doesn't, oh, give me a second. So everybody got the important stuff from here? There's not much in here, so I'm gonna stop sharing. Bam. Oh, let me spotlight myself because it's all about me. Ta-ba! I have power. Okay, let me see. Let me get this up here. I should probably, okay. So we got the claim. Let's see, this is number 80. We got the claim is P equals 0.6. You always, when, Jeff? Always. Tuesdays? Yes. Always make a percentage into a decimal. Dear God. Okay. So, of course, which one's that going to be?
The hoe.
Right. I like it. Is Jeanette getting some kind of a thrill from saying that? I'm glad I could do that for you. Okay, and then part B is, can we use Z or nothing? For percentage problems, it's Z or nothing. What do I have to check? Somebody else. You know what I'm talking about, Jim. All right.
If it's normal or not.
Yes, and in this case, how do I check to see if it's normal?
NP and Q.
Good. What's N? Does somebody have that open in their book?
64.
Yeah, they talked to 64 people. So N is 64. And what's P?
0.531.
Oh. 0.6. What's 0.531 sounds like it might be P what?
Oh, P hat, sorry.
There you go. I like it. Let me stop for a minute. You guys, so don't sit there and agree. Sit there and say, would I have known to do that? Would I have known to do that? If not, you say, why do you know to do that? Or something, right? So don't just sit there and agree with me as I do this problem. Can you see why I'm doing what I'm doing? What's Q?
0.4.
0.4, I like it.
2.4.
I like it. So whatever that is that 38.4?
Yes.
Which makes this one 25.6.
Yes.
Woo! All right, cool. I like it. So that means that it is normal enough. Check. So now I can set up my rejection region. What was it? Did they say? See, another thing about this is they don't give us an alpha, do they? And somewhere they do say, what is the most commonly used alpha? Does anyone remember?
0.05.
Yes. So they don't say you use 0.05. This is a one or a two-tailed test.
Two tails.
2.
Oh, let me say this, guys. Here comes a very important note. Bless you. Very important note to take. You ready? I don't normally highlight notes like this, but do not use the worksheet that the book provides for these problems. Do not use the worksheet that the book provides for these.
Yeah, I was going to ask you that because that was throwing me off as I was doing my homework.
Thank
And
you.
I much prefer the way that we do it in class.
I always forget. This book is a little too heavy, reliant on calculator, which is really bad. But yeah, so the way they do their worksheets all backwards because they get all the final answers first and then they look at it and do shit and it's like, all right, wait a minute. Everybody with me? And yes, anytime the alpha is not given, you use 0.05 because that's kind of like the standard. All right. So it's a two-tailed test, 0.05. We're using z-scores. Can somebody tell me what the rejection region will look like? There's my little ghost dude. All right. Two-tail, 0.05. So this actually mimics what we considered unusual before. Can you guys find that?
Is it 1.960?
Yes, I like it. Sounds like you looked it up on the z-score chart. I like it. Does that sound familiar? Remember way back when we first talked about unusual wasn't 2 steps away? Yes. Which is basically what that is. Go ahead, sorry. Somebody was about to say something. Everybody all right? Okay. So can we say this? Can we put this in words? If Z star is what?
Less than negative 1.96 or greater than 1.96.
We can do what?
Reject the hoe, support the high.
If you learn nothing else from college, reject the hoe, support the high. So it's the 80, and now we're at D. So now what we're talking about, what we can use to talk about it, what's going to show evidence, and then do we find evidence? All right, so what's P hat going to be? I don't know if you guys have your book open, but they talked to 64 people and found 34 of them felt more enriched, like wheat bread. Sorry.
0.531.
Yeah, so that was from earlier. So 34 divided by 64. I'm going to take your word that is 0.531. And yeah, somebody private chatted me earlier. Yeah, don't do what the book tells you for 9.5. Don't do their worksheet. Do our normal 5 steps. Our 5 steps are the same as theirs. Theirs are just turned all around and bullshit.
If I've already done some of the problems on there using the solution sheets, is that okay? As long as I just continue on with the way we do it in
Yeah,
class?
you're fine. Yeah.
Yeah, because I don't want to have to go back and do it all over again.
I understand. It was my fault for forgetting to say something, so I'm not going to penalize you. So now we got this sort of new formula here, right? Why am I forgetting what I'm doing? I don't know. All right. Right, so this will be our data, 0.531, minus the supposed true percentage, divided by the square root of 0.6, 0.4 over, what was it, 64. There we go. So one big mistake people make is that when you don't put in the calculator correctly. Another thing is The only place any hatted thing shows up is right there. That's it. That's the only hatted thing. That sounds like a type of bird. So it's the hatted blue warbler. So Z star, let's see. Where's my calculator? I have no idea. There you are. Do, 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 do. All right. Ooh, I get something. What do you guys, anybody got it?
Negative 1.13.
Yeah, let's see. Is that what I got? Yeah, that's what I got. 1.13. Can you please take a minute and figure out the p-value? Figure out the p-value. Jeff, calm down. Let's see. I'm going a little stir crazy, I think.
Is it 0.2584?
Yeah, I should probably look it up too, shouldn't I? Let's see. Anybody else get that same thing? Let's see. Where are you? Where are my z-score charts?
Yeah, I got 0.2584.
So you got something and then you double it, right?
Yes.
Okay. So remember, it's a two-tailed test, right? Two-tailed test. What the hell is a p-value? Is just the area in the tail or tails that my z-score makes. So if you look up negative 113 in the negative z-score chart, you'll get 0.12 something. And then you double that because it's a two-tailed test. So the p-value, I've already forgotten. What was it? 2584?
Yes.
Okay. And now remember this. This is really huge. The smaller the p-value is, the more evidence that is against the null. So just looking at the p-value, that's not good. That's not good. That's a 1 out of 4 chance. That's not a very small chance. That's a pretty big chance. And also, of course, negative 113. Did we make it far enough away visually?
No.
No, we made it to like right there. We suck. All right. So what would I have left myself no room. The conclusion, the claim was the null. So I'm going to use this language. But did we succeed or fail? We have epically failed, kids. Is that what your kids say? All right. We big time failed. We failed bad. Real talk, guys. We failed. But that doesn't mean we did anything wrong. It's just the way the test came out. I'm going to write the conclusion in a minute, but how's everybody doing with this? You guys all right?
So another way to look at that, the book refers to it as if the p-value is less than alpha, then we reject the hoe, right?
Yes, exactly. If the p, because it's sort of like another way to look at alpha. Another way to look at this is as a threshold. I said the p-value's got to be small. The smaller it is, the more evidence against this dude, right?
Mhm.
So this is the threshold for what makes it small enough. So if our p-value would have been less than 0.05, then we would have rejected the null. The nice thing is the results we get by just looking at that dude right there, that dude, this dude, just visually I could see, we didn't make it, would line up perfectly with results we get from looking at the p-value. They agree completely. So you've got two places to look to get your answer, and they both should agree with each other. Does that make?
Yeah.
Okay, good.
I'm just a little confused on part B, where we're testing the NP and NQ. Can you explain how you got like the 38.4 is greater than or equal to 5? Can you explain how you got those?
All right, now this is part of the test, right? Just like n greater than 30. Right. Okay. So that's a given. That's the whole point of the test. And this is just what I got from doing this. 64 times 0.6.
Oh, got you. Okay. I was reading it wrong, but I
Ah.
get it now.
Good. All right. So let's try to write the conclusion. I'm going to erase this here up here. I should have, I'm going to say this again. I should have gotten the bigger. It's all right, Jeff. It's all right. All right. So finally, step E, we have, good Lord, not found sufficient evidence to, and remember, we're using the reject language, failed to reject. We have not found sufficient evidence to reject the claim that I totally forgot what this is about. It's where you go back and you, oh yeah, that's right, the enrichment thing, I love it. That the percentage of her students, the percent of her students who feel enriched is 60%. Something like that. You could even say that 60% of her students feel enriched. You could even, make it better. Oh, yeah. All right. Somebody's requesting me to show you the thing in the calculator. Let me do that. So I'm going to turn give me a minute. Let me get this guy waking up. Oh, man. Wow. I feel better today than I did last week. All right, let me see. Get over there. Cooperate. There we go. Beep. Look at that funky graph. I love that graph. All right, we'll get away from the graph. So here's what the formula, I'm guessing you mean for Z star, right? So yeah, Jeff, that's the only formula we did. So that's 0.531. Okay, I missed that. Minus 0.6 divided by the square root of 0.6 times 0.4 divided by 64. See, so I don't know if you have the calculator where the square root grows like this, or do you have the calculator where there's a parenthesis there? I mean, it's.
The other one, yeah.
All right, let me see, what could this do here? Bam. So then it should look like this. See how the parenthesis is not closed until the end. So all of this is in the square root. Do you see that?
Yeah.
Okay.
Okay,
So
thanks.
the top has got to be in parentheses so that it knows all of this is on the top, divided by, and don't close that parenthesis until you get out of there. And of course, if you do have the Scheisse, if you do have the newer math print kind of thing, then the square root sign gets bigger. It's a little bit easier to see that it's all there. Okay.
Okay, thanks.
You're welcome. Anytime. All right. How's everybody else? We've done a lot of these by now, right? And the neat thing is, no matter if it's T or Z, no matter if it's means or percentages, the flow of the test is the same. Are there differences specifically? Of course, if I got percentages, I don't want to do n greater than 30. That doesn't mean shit. I need NP and NQ. And I need a Z-score that's got P's and Q's in it. So of course those are going to change, but I still have to show it's normal. I still have to get my Z star. You know, I'm just using a different test for both of those, or a different formula. Okay. I have no idea. You guys feel any better about that? So a lot of you guys have yet to step into section 9.5. So now that you know not to use that worksheet, it will be simpler. You just follow the 5 steps we did. If you need help with that, you can download the worksheets that I put up there. They have all 5 steps explained. Remember that problem with the northern Minnesota coyotes? That feels about 3 years ago that we did that. Or maybe in 2020 terms, it feels exactly as long ago as it was. Because holy shit. Isn't it? It feels like it's 2025. All right, here we go. How are we doing? Anything else? Any other questions you guys have? Any other concerns before we get into the one section we're doing in chapter 10? All right, so this is exciting. So the one section we're going to do in chapter 10, I didn't want to get too lost in the weeds on this, so I'm not going to do the other sections in 10. And I'll talk a little bit about why that is here in a minute. But I want to start with, here's the idea. So I gave a problem a while back that said, okay, I got this old drug and I know it takes this long to work. So I had a known mean to work against. I had a known population mean to work against. Are you guys with me? How does a drug trial normally work though? I have this new drug, right? What do I actually normally test for with some new drug?
Does it work?
Yeah, there you go. I love it. That's the perfect way to put it. Does the damn thing work, right? Sort of like the Pfizer vaccine that we're all hoping for and that Trump tried to take credit for, and the people from Pfizer said, no, but I'm sorry. Yeah. So what I'm going to do then is, let me see, is that a good one to do? So I'm going to have people that get the actual drug and people that get a placebo. So I have no idea what the statistics are for the populations those two come from. So I don't have a known mean. I don't have a known mu to work against, right? So this will be a claim about how two population means are related to each other. So for example, let me see. Let's say I have, yeah, sure. We give a drug to 2 groups, right? Not a drug. Yeah, let's do it this way. We give a drug to 2 groups. One group is younger, is a bunch of people, is young people. What the hell? Let me just say young people. And the other group is not so young people. Not so young. All right. I'm getting too old for this shit. So this is a little bit different. This is another way we could do a drug study, is to see if it has any effects, different effects on different demographics or different situations. So I notice in group 1, that'll be these guys. I'm not even, screw it. I don't even know what this is going to be for, but we found a mean of 13.97. We found, and we happen to know the standard deviation. This is the part that's not so real, but oh well, too bad. We know the standard deviation is 5.02, and there were, let's say, 89 people in that group. So one thing to realize is, since I'm testing the difference between two populations, I'm going to have to take a sample from both of them. So that's why I'm saying X bar 1, sigma 1, N1, because there's going to be a whole other sample from group 2. Say X bar 2 is, what do you got, buddy? 18. Yeah, they were higher, whatever the hell that means. We know that the standard deviation is, let's say, 7.13, and there were 71 of these people. So we run into a couple of snags here. The Z-score formula. So the standard Z star. Let me let you guys, has everybody finished copying that down? I don't want to block it. So now stay with me now. This is where things get interesting. So the standard Z star formula only has room for one sample mean, right? You guys with me? So here's what we got to do. Let's see, which order do I want to do this in? In fact, it's only got one sample mean also. One population mean that it compares to. So here's what's going to happen. All right, so let me go ahead and do it this way. This is going to become, let me see if you guys can handle this. Let's see, which way do I want to do this? Sure, okay, we can do it that way. So everything gets doubled. I have a sample mean with its population mean and another sample mean with its population mean. And then the really, okay, I really want you guys to be with me on this. So I just doubled everything on the top because there's two of everything. There's two samples and there's two populations those samples come from. Right? One population here is younger people and the other population is older people. And these are the samples I took in my results. So there's two samples and two populations. So what the hell is going to happen to this dude? That's going to be freaky. All right, so I'm going to take this away for a minute. You know what the setup is. So let me work on this guy up here. Are you guys... Remember, what is sigma x bar anyway? The shit is that? That's sigma over the square root of n, right?
Yes.
Yes, I like it. So what's sigma x bar squared? That would be sigma squared over n. Is that cool? Yes. So what happens is if I double the number of sigmas and n's, I end up with this. And we normally call that kind of our pooled variance. So this is effectively how we incorporate two separate standard deviation pieces of information together. There's a lot of interesting math behind why it's exactly that. But it still matches the idea of I'm doubling everything because I have two populations and two samples now. Therefore, this guy is going to be the square root of this business. So this is going to be So let's try to, okay. Let me reorganize things a little bit. I know this is gross. This is always the grossest part. And this is always the part you guys get the most freaked out. I'm deriving a formula, and right now you're like, am I going to have to do this myself? No. I'm going to have to explain. No. We're creating a formula. There's the formula. I want to redo this a little bit. I want to reorganize this a little bit. So here's what it's going to look like. Let me do this in, I have no idea, purple, sure. Holy shit. No idea why I'm being extra creepy today. Okay. Whew. So it's still our data minus the supposed middle divided by the spread. It still is. The basic idea of the formula has not changed. Are these the steps I was assuming for me to do the job? I have no idea. Not for every test. I mean, the steps that we do works for hypothesis tests, but there are other kind of tests in statistics for sure. So now watch this, guys. What do you think I'm trying to test for with these two groups? Remember, this is this is the younger group, and this is the older group. What am I trying to test to see? What am I trying to show evidence for when I conduct a drug study with two different groups of people?
There's a difference between the two groups.
Trying to see if there's a difference. I love it. So what would the null hypothesis be? We're trying to test if there's a difference. So what would the null be?
There is not a difference.
There is no difference. I love it. So the null is going to very often is going to be mu1 equals mu2. And then the alternate will be mu1 not equal to mu2. Is it always like this? No, but like always, this includes the possibility of equality. Is everybody with me? We knew that going in. That's why we do this, is to see if there is a difference. So you're trying to show evidence for a difference, which means we're working against the idea that they're somehow the same. If mu1 equals mu2, what's this? If
Zero.
mu1 equals
Zero.
mu2, what's mu1 minus mu2?
0.
0. Goes away. So then your formula just becomes that. So let's try this formula out with this data here. Right, so let's write down what this thing would look like, and then I'll do it in the calculator with you guys. Calculator. So just plugging everything into the formula. X bar 1, 13.97, minus 18.12, divided by square root of 5.02. And the big mistake people make is they forget to square this poor little dude, divided by n1 plus 7.13 squared, divided by 71. Now I'm very curious. All right, so let's see what that looks like in the calculator. Ow. Wow. All right, let me see.
Are we just squaring the variance or are we squaring the whole thing? Just,
Yeah, it's sigma squared over n1. Yeah, it's not. Yeah, is that cool?
yeah, and
Only
are we
squaring,
just
standard deviation? Yeah.
assuming that the mu is 0? Because it doesn't.
We're not assuming anything. So the null hypothesis must be that they're equal, considering that the point is to test to see if there's a difference. It's a good question still. I don't want you to get, we aren't really assuming it. It's just a part of the test that, and I guess in a way you're right, because we always go into a hypothesis test assuming the null is true in some way. So in that respect, yeah, we're doing the same thing as always. We're using this to be the truth, which makes this go away. Right?
Okay, thank you.
Will it always be like that in real life? No. Is it like that most of the damn time in real life? Yes. So that's why I want to focus on this kind, because this is what normally happens. Let me see. How's everybody else? Any other questions?
I had a question.
Yes.
So when we're using this equation, like later on, we just kind of ignore the mu's at the top.
Yes. The kind of problem where you wouldn't is if they said, test the claim that the younger people have a mean that's 4 points higher than the older people. Then the mu1 minus mu2 would be 4, right? I mean, so it's, but you're not going to see that in the problems that we have. So yeah, basically you're right. Just like I said, the formula does become this for the problems we're going to do. Ignoring the mu's, right? I like it. So here's what it looks like in the calculator. Let's see. So again, tell the poor little calculator what the top is. No, Jeff. Why am I using my mouse? Because I am. Boop. Divided by square root. This is exciting. Divided by 89. What'd you enjoy most about statistics, honey? Watching my teacher push buttons. All right, divided by. I'm not saying anybody sounds like that. All right, looks like everything's in there. Let's see what happens. Ooh, yeah, cool. I was kind of trying to make this come out to be a little extreme. How's everybody doing? Are you getting that same number?
Yes.
Okay. Do I even need an alpha to check this out? What do you guys think about negative 4.15 as a Z star? How do you feel about that? Anybody?
It's far out.
It's way far out. Holy shit. If we looked up the p-value, it'd be about 0, right? What's percentage is more outside than this? About 0. It's going to just about kill any alpha that we give it. Does that make any sense to anybody? In an actual problem you have to do, they're going to give you alpha, so don't freak out, right? But this problem, I kind of set it up so it wouldn't be that way. I do have a whole problem we're going to work on, or you're going to work on, and I'm just going to sit here and wait. Okay, so let's do that. If nobody has any questions about that. And what are the steps? What are the steps, Jeff? Well, the steps are the same 5 steps. Just the 4th step, you're going to use this formula. Ooh. And the 2nd step, both sample sizes have to be bigger than 30. One big reason I didn't want to do the t-test for 2 sample means is it is remarkably disgusting, the formula to use to figure out the degrees of freedom. And think about it. If I had to do degrees of freedom, I've got 2 freaking samples. The shit do I do? Sometimes it's simple and most of the time it's disgusting. So anyway, that's the last I'm going to say about that. So if you are able to, if you would please go to Canvas because I have put up in Canvas. Get out of here. Where is it? Here we go. In the modules, I have put up in chapter 9, which I've now renamed 9 and 10. Right down here, 2 populations. Boop. So that's the sheet I want you to work on right now. So if you look up here, now notice up here, I just gave you X bar and stuff, right? Here I don't. So you can use 1var stats to get what the X bars are, right? Do I tell you what the sigmas are? I think I heard a yes.
Is it, yeah, is it 0.05?
No, that's alpha.
Oh,
I'm
what
going
was
to tell you
that?
what the sigmas
Oh,
are.
yes.
Yes, right here, right? Standard deviation for all female grades is that, and for all male grades is that. All right. I like it. So go ahead and try this out. Let me pull it up a different way here. Oh, here we go. Where are you? There you are. Where'd you guys go? There we go. That's better. And I do want to, let me try how to, I do want to publicly apologize that I still have problems from before that are broken into the 2 genders that we now know there are more than those genders. So if anyone is offended by that, I'm sorry. This is an old worksheet that I had easily available. So we're just going to go with it. Pretend like it's from 1960. And if and I apologize again, but we're going to do it anyway. We're going to use the data. I'm going to be right back. I got to take a little break. All right, let's see. Oh yeah, Bluetooth mode. Bluetooth connected.
Bluetooth connected.
Thank you. Okay. Ooh. Oh yeah, I should probably do that. Oh, that's pretty nice. Do that. Bum, 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 bum. Oh, interesting. Is this really quicker, Jeff? No, it's not really quicker. All right. Oh, I like it. All right, sweet. Do. Really, Jeff? Fashion 6. Putting on the list. Do. I'm going to put down what I got for the means. Let me see where I put you for later here. Make sure you can get this. Well, okay, do that if you want to. Oh, Scheisse Meisse. Rah. Oh, 12, okay. Night has come. Cleanse dark. Is the only I will see. Now I won't. Oh. I'm going to kind of catch up to you a little bit. This first part might be a little tricky if you weren't paying attention to what I wrote on the board. Does somebody know what the claim is?
mu1 equals mu2.
Yeah, u1 equals mu2. Kick ass. So where's it going to go?
The hoe.
Genetic. Such language. Why couldn't my dean have come to this meeting to evaluate me this semester? She came to my other class. Jeff, they were talking about hoes. All right. So with two samples, with two populations, there will actually almost never show any numbers in these hypothesis statements. They are relationships between unknown things. Both of these are unknown now, right? Is this a 1 or a 2-tailed test?
2.
2.
Big ass. I like it because it's not equal to. Are we allowed to use z-scores?
Yes,
Why?
it says the distribution is normal enough.
Big ass. Normal enough. Check. And
We have sigma.
sigma is known. Each sigmas, let's say, are known. Kick ass. All right, let me stop for a minute. All right, Jeff, you can make it. All right. So now I got alpha of 0.05. And again, we just did this basically. It's 0.05. It's a 2-tailed test. This is the one we just did, remember? So this would be negative 196 to 196. So it'll be the same thing. If z star is greater than 196 or less than negative 196, we can reject. What can we do, Jeanette? We can reject the null and support the high. All right. Now, what's going on outside? One of my neighbors is a Trump supporter. So when I hear big machinery start up, I get a little worried. All right. He had a drone with the Trump banner flying on election day.
Oh my
Kind of wanted to see it crash as the results came. But anyway, what am I talking about? I'm not talking about anything.
Oh my gosh. That's fun.
Oh my gosh. It wasn't worth that. Was it? Was it worth that? That was a little extreme of a reaction. It wasn't. I didn't say crash into the person. That would have been an oh my gosh situation. Let me see. 11.09 and 12.33. By the way, before we get too far with this, do you guys see? Now this is huge. I got to make a big deal out of this. I'm going to call females group 1 and males group 2 just because that's the order that the data was given to me. Are you guys with me?
Mhm.
You have got to identify what group 1 is and group 2 and keep it consistent. It especially is important when I have a 1-tailed test. Okay, so now I went and forgot. For my women, it was 11.09 for the standard deviation, and my dudes were 12.33. What does mine say? Sweet. And now take a minute, if you haven't already, and plug all that into the equation. Let's see what happens. Holy shit, Jeff. Interesting. Most interesting. Yeah. Did anyone get an answer yet?
.90.
Yeah, I got freaking 0.90. Yeah, exactly. That's the smallest Z yet. So on the surface, it looks like these two grades. Let me see, what was this for? Yeah, okay. It looks like these two grades are really different. I mean, they're a good 4 points apart. but because the standard deviation was pretty large and the samples are pretty small, that all ends up meaning that they actually weren't that far apart. So we definitely have failed. We got to about right. So here's 0. Shaboop, and we got to about right there. Shaboop. We barely left home. Good job. I'm running away from home. And then you go to next door. So we have, again, we have failed to reject the null. And we have failed to support the high. So take a minute and try to write the conclusion if you haven't already. Oh, mi macarones. Oh yeah, no. That's right. Oh yeah. Oh shit. Oh, screw it. Okay, so let's see. The claim went in for the null, so that's going to be what I base my conclusion on. So I'm going to use this language. I am not going to use this language. Failed becomes we have not found sufficient evidence to reject the claim that the mean grade is the same for men and women. How you guys doing out there? Everybody okay?
So if we chose the statement of fail to support the high, would we still use the phrase we have not found?
Yeah, because we failed.
Okay.
Yeah. So anytime you fail both of these. So then no matter which one the claim was, it's going to start with we have not found. So you only say we have found if you make it in the rejection region. Otherwise, we have not found. Yeah. And remember, what was it was our claim, right? Let's just pretend it was our claim. Test the claim. So let's say we claim that the means are the same. Didn't we fail the test? Are we sad that we failed the test? Are we sad that this test failed? No, we if that's our claim, we don't want this claim to be rejected, do we? Do you guys understand what I'm saying? If that's our claim, we don't want it to be rejected. So we do the test and it's like, oh, we failed to reject it. Good. Yay. Maybe. So, just saying you failed doesn't mean a bad thing. It just means that the test did not see evidence that that thing was wrong. So if you're rooting for that thing, you're actually kind of happy that it came out that way, right? Was there a question? I'm sorry. No. Okay. So that's section 10.2. The same 5 steps, same 5 steps, just a larger formula here, which only makes sense because it's got to squeeze twice the information into it. So of course it's going to be bigger. Last thing I want to show you, I'm going to stop sharing. Does anybody still need something up here? All right, I'm going to stop. Here goes. Let me show you. I didn't put this data in here, and I'm not going to, so too bad. But I do want to show you something real quick. If you had your data, let me see, I've got stuff in here, right? So let's say that that was the, and just to prove to you that it doesn't matter how big these are, let me put one more piece in there. All right, so let's say the data is the same we used. I know it isn't, but too bad. I don't want to put data in there. If I go to stat test, which I would hope that somebody out there would think, oh, we're doing a hypothesis test. So if you go to tests, look what I can see here. Look at this, 2 sample Z test. Oh, let me go down here. Let me do this thing. And then it says, do I want to input data or statistics? Well, I want to input data, right? And here's where you could put your, whatever that standard deviation was. And remember, my data is not the right data. You guys remember? And then whatever the other one was, I don't even know. I can't remember. And then you tell it L1 and L2 is where your lists are. They're all frequency 1. You make this mu1 not equal to mu2. Do you guys see what I'm doing here? It pretty much mimics our kind of our steps that we take. If you want to draw, that's the color. So let's calculate. And then here's where you'd see the Z-score and so forth. You think, did I do it in here? Yeah, I did it in this calculator, unfortunately. So let me try to show you this. Let's see what happens here. All right, all right, this is gonna be interesting. All right, I gotta focus. Let me pull up my focus, dude. All right, here we go. Give me a second. There it is. Look at that shit. Does that look familiar? The only thing that we didn't get was the p-value. But you know, this is a place to check your p-value. Look at that battery. That's looking pretty good. Ah, what happened to me? Oh shit. Parallel universe. Oh shit. Oh shit. Okay, stop. sorry. The simplest dumb things just really make my day. All right. All right, guys. Let me think. I mean, that's all I really had. I try to save some time in case somebody had some specific questions. We're done with chapter 9. We're done with chapter 10. Wow. Wednesday's a holiday. Holy shit. And the next quiz, when is our next quiz? I can't remember off the top of my head. There it is. All right. Supposedly our next quiz is, yeah, November 18th. So next Wednesday. That sounds good. That's plenty of time. Yeah. So I still got I'm going to throw chapter 10 up there. But a lot of people aren't really done with 9 for sure. Okay.
What would happen if, so we solved for Z star and it was exactly equal to, like for this case, if it was exactly equal to 1.96, would we still have to reject it because it's not greater than 1.96?
Well, we would actually fail to reject because of what you just said, right?
Oh, yeah. Yeah.
That's a really good point. The likelihood of that happening is so minuscule so that if it ever does happen, statisticians would, you know, go to the rooftop and say, I got it to equal it exactly. And other statisticians are like, holy shit, really? Because it doesn't take much. What would more likely happen is you would just go back and see if there was anything you rounded, right? But technically it has to be greater than, not greater than or equal to. So that's a good pickup. If you get exactly 1.96, you still failed. You didn't get greater than 1.96, too bad for you. So that's a good question.
Okay, thank you.
Any other questions, guys? You guys all right? I mean, if you guys don't have any questions, I'm done. I've done everything I wanted to do. Can you show us how to input that equation into the calc? because I keep, oh, let's see. Oh shit, I'm sorry. I put my calculator to sleep already. Let me wake him back up. Oh, there you are. All right. Is it still in here? Let's see. Here we go. Shit. What's happening? There we go. What's happening? All right. Is this it? I think so. All right. So see it? Do you need to see it the other way? Does your square root not grow? Whoever was asking me, do you need to see it the other way, or is this the way your calculator looks? Here we go. I got chats. Oh shit. Chat, show up for me. There we go. Okay, let me show it to you the other way then. Oh, somebody wanted it this way. So now you see it this way, right? You got to tell what the top is. So you got to put in parentheses. And then you got to just make sure all this business is in the square root. Now, if your calculator is the other way, oh shit, there we go. Then get over there. It would look like this. Let me pull this back up here. Bam. So then, oh, this is interesting. You would want to make sure that the top is in parentheses and that see this parenthesis right here? I don't want that closed until I get all the information in there. If you close that parenthesis too early, you're outside of the square root. Does that make sense? That's what it looks like on an older style calculator. 2 sample z-test. I missed the part where you explained the mu1 is not equal to mu2. How do you change it? Oh, okay. So going back to the test, there is no way to change it to equal to. Of course not, because these are options for H1. Do you guys see that? This would be the high. Does it make sense? Because there's no equals. Not equal to, greater than, less than. So it's totally dependent on what your high is, what your H1 is. Okay. So there could be a claim where we say we think that the women scored higher than the men. Then that would have been mu1 greater than mu2, right? How to find the p-value. Okay. The z-score we got. Let's get this p-value. The z-score we got was 0.9. Let me pull up my z-score chart. Z-score chart. Where the hell? Okay, here you are. There you are. Get up there. Now get over here. All right. So right, we got 0.9 for the z-star. So if I look up 0.9, 0.90, 8159. You see that? Which means the area in the tail up here, right, in the tail would be 1 minus this. So 0.1841. .1841. And then if you double that, you'll get the p-value. Why do I have to double it? Because it's a 2-tail test. If it was a 1-tail test, I would stop at 0.1841. Okay, cool. I like it. Everybody else all right?
For the claim when we're doing that, we don't use the numbers, right? The numbers don't come until after.
That's right. The problems we're going to do, you'll never see a number in the claim or the hypotheses. Like I was saying earlier, there could be a claim where we say, we believe that the population mean here is 9 more than the population mean theirs, in which case the number 9 would show up. But for the problems we're going to do, it's going to be mu1 equal mu2 or mu1 less than mu2 or something like that. Yeah.
Okay.
Anything else, guys?
That's it. Have a good one.
All right. I'm going to officially call it. So let me know if you need to hang out. Otherwise, a nice early day. Get into that section 9.5 so you got some questions.
Bye, everybody.
Bye. Have a good weekend.
Whoa, I'm out of here.